Hi, welcome to today's video. Today we're going to talk about graphs of quadratic functions. Now in the previous video we talked about the three different forms of a quadratic function, and so I have those reviewed here for you today. So just remember the graph of a quadratic form or a quadratic function is a curve called a parabola. The different forms of a quadratic function are, first of all, the standard form, which is y equals ax squared plus bx plus c. Remember, a, b, and c are just real number coefficients. One thing I didn't talk about yesterday, but I want to mention today, a parabola opens up if a is greater than 0, and it opens down if a is less than 0. So think about opening down versus opening up, like this. Okay, and again, just to review, the vertex is at negative b over 2a and f of negative b over 2a. Our vertex form is y equals a times the quantity x minus h squared plus k, or f of x equals a times x minus h squared plus k, and the vertex is located at hk. Factored form is y equals a times the quantity m minus n times m minus n, and this is also called intercept form, so it could be interchangeably called factored form or intercept form, depending on the directions or whatever. The x value of the vertex we talked about is halfway between the two x-intercepts. Remember, we have that axis of symmetry, and our parabola has to be symmetric. And so if we have 2 points that have the same y value, the axis of symmetry has to be halfway between those 2 points. And our two x-intercepts, of course, are m comma 0 and n comma 0. The vertex, of course, is just at either the bottom point or the top point, the minimum or maximum of the graph. And of course, the axis of symmetry has to go through that vertex in order for it to be symmetric. And again, that axis of symmetry is just the line of symmetry of the graph of our parabola. Okay, so let's look at graphing from our three different forms. First of all, we're going to start out with standard form. So what we're going to do is graph each quadratic function, and on the graph we're going to label the axis of symmetry, the vertex, and the y-intercept. When we get to factored form, we'll label a few more things, but for now, just those three. So in our first example, we have y equals x squared minus 2x minus 2. So remember, our vertex is located at negative b over 2a. So here our a value is 1, our b value is negative 2, our c value is negative 2. We just need the b value, which is negative 2. So negative 2 would make this positive 2 over 2 times a. Well, a is 1, so 2 times 1 is also 2. So 2 divided by 2 is just 1. So on my table of values here, I've chosen some values that I'm going to find the x and y value of. In this case, 1, this one happens to be the vertex right here. So we're going to find f of 1. So when we find f of 1, we're going to put in 1 for x. So 1 squared minus 2 times 1 minus 2. So 1 squared is 1, minus 2 times 1, well, 2 times 1 is 2. So 1 minus 2 is negative 1, minus 2 more is negative 3. So this is at 1, negative 3. Okay, and we know our axis of symmetry is at x equals 1. So I'm going to go ahead and just draw in our axis of symmetry on our graph. Okay, so we have the axis of symmetry. And I'm going to go ahead and label it as x equals 1, because that is the equation of that vertical line, x equals 1. Okay, our y-intercept. Well, our y-intercept, remember, is always f of 0. So I'm going to put 0 in for x. So 0 squared minus 2 times 0 minus 2. So 0 minus 0 minus 2, that's negative 2. So 0, negative 2, there is our y-intercept. 1, negative 3 is our vertex. So vertex 1, -3. Okay, now notice that 2 right here, since we already have the value 0, -2, and it is 1 away from the vertex, this other point has to also be 1 away from the vertex, and it will have the same y value as this point. So we have at 2, we also have a value of -2. So that is another point on our graph. We might want to find just one more point on our graph so that we can make a nice smooth graph. So I'm also going to find f of 3. So f of 3 is 3 squared minus 2 times 3 minus 2. Well, this is 9 minus 6 minus 2. 9 minus 6 is 3, minus 2 is positive 1. So that gives us the point 3, 1. So 3, 1 is located right here. Remember, we also have another point on the other side of the axis of symmetry from that. So if this is 2 away, if I go back 2 more, we have another point right there on our graph. So that is how we can use those corresponding points to help us graph, is if we know where this is, we know there's another point on the other side of the axis of symmetry from it. It's a nice, easy point to graph. So now go ahead and we will just make our nice, smooth curve from there, and we have our graph. I have labeled the vertex, I've labeled the axis of symmetry. I just need to label the y-intercept, which is right there, y-intercept, and it is at 0, -2. There we go, we are done. Okay, next one. Y equals -1/2 times the quantity x plus 1 squared plus 3. So remember, the vertex, since this is in vertex form, is at hk. And remember, we need x minus h plus k. So our plus k is 3. So remember, if this is minus h, this is really minus a -1 to give us the plus 1. So -1. So -1, 3 is on our graph. So -1, 3 is located right here. That is our vertex. Now remember, our axis of symmetry has to go through that point. So let's go ahead and draw in our axis of symmetry, x equals -1. I've labeled it. We're good to go there. Okay, so our y-intercept, we need f of 0. If we put in 0 for x, 0 plus 1 is 1. 1 squared is 1. Times -1/2, still -1/2. So -1/2 plus 3 is positive 2.5. So I'm just going to put 2.5 here. We could make it 5/2. Either way is fine. Okay, so we have 2.5 here. So we have that point. Remember, we have another corresponding point that's the same distance away. So we have another point here at positive 2, 2.5, or sorry, -2, 2.5. Okay, now we should find probably just one other point that's easy on the graph, just to make sure, because these points don't really give us a lot of information about the graph. Let's find one other one. Let's find f of 1. So if we put in 1 in for x, 1 plus 1 is 2, 2 squared is 4. 4 times -1/2 is -2. -2 plus 3 is positive 1. So we have the point 1, 1 located right here. And remember, that also tells us another point. So this is 2 away here. So if we go back 2 from -1, we're at -3, 1 right here. Now we have enough information to go ahead and sketch our graph. So draw that in. That's supposed to be an arrow there. Okay, and there we go. There is our graph. The only thing we need to do now is label. We have the axis of symmetry. Our vertex is at -1, 3, vertex, and our y-intercept 0, 2.5 is our y-intercept. And there we go. We have everything labeled now on our graph that was asked for. Okay, so we're done with that one. So as you can see, it's really easy to find some points on our graph. We found our vertex, we found our y-intercept, we plugged in one other value to be able to find it. That gives us about 5 points for our graph, plenty of points to graph. And we were able to do that for both of these particular forms of our equation. Okay, our last one will be, now we have intercept form, or factored form, either way you want to call it. So first of all, remember our intercepts. This is x minus m and x minus n. So in order for this to be minus, we really need to think of this as minus a -7. So our x-intercepts are -7, 0, and -1, 0. Okay, so we have -1, 0, and 2, 3, 4, 5, 6, 7. -7, 0. Okay? So we have our two intercepts. Now, remember that our y-intercept is where we have f of 0. So if we put in 0 for x, 0 plus 7 is 7. 0 plus 1 is 1. 7 times 1 is 7 times -1/2. So this is -7/2 or -3.5. Either way you want to call it. So 1, 2, 3.5. -3.5 is located right there. Okay. Now we have our vertex. The x value of our vertex, remember, has to be halfway in between these two. So if we take -7 plus a -1, remember that was our two intercepts, we add them together, divide by 2. So -8 divided by 2 is -4. 1, 2, 3, 4. Our axis of symmetry has to be here. X equals -4. Okay. And if we put in the y value, -4, so -4 plus 7 is 3, and -4 plus 1 is -3. So 3 times -3 times -1/2. So this is 9/2. Actually, it's positive 9/2, or 4.5. So 4.5 in the y direction, 1, 2, 3, 4.5 is right about there. Okay, so one more over here. If we go one more over here, we have this point on our graph right here. That's about right. And we now have enough information to graph our parabola. Okay, and as long as you show that you found approximately 5 points on our graph, really we're finding 3, and we're given the other 2 because we're symmetric. So we have our 5 points on our graph. So our axis of symmetry, x equals -4. Remember our x value, that's where our vertex is, so we need to label our vertex. -4, 4.5 is our vertex. We have 0, -3.5 for our y-intercept. Our x-intercept is -1, 0, and -7, 0. Okay, so, and now our maximum value, well, that's 4.5 is our maximum value. So we have found everything that we need on our graph here. We've labeled them on our graph. Vertex, this is also our maximum. Okay, so we've labeled everything on our graph. So we're done. So I hope that that helps you to graph quadratic functions. And so thank you for watching. I hope to see you again soon.